Okay, so I want to try to attempt to cover the Dubai cloud outage. So what happened? Well, why don't we just Google Dubai? Our strategies. So our strategies can be 1, okay, couldn't find caps lock, 5 whys, and assumption inventory, and also blank slate method. Okay, so zoom out a little bit. Okay, using this weird mouse. It's like there's no, it's like a Microsoft Arc, I think it's called. There's no scroll wheel, which I kind of hate. It's not tactile enough. Okay, maybe we can start in the assumption inventory, because the first thing that I would assume is we won't get missile strikes, which is not a laughing matter at all. It's very serious and very upsetting at what happened. So they made that assumption. What else did they assume? From what I heard, they probably assumed that multi availability zone is enough. And even from what I've seen, usually people treat multi-region as like overkill or even luxury, which is ironic because this is Dubai. What other assumptions are there? EC2 RDS dynamo with DB disrupted slowness on API calls. More assumptions. They probably also thought that, cloud is cloud, as in like maybe cloud is in the cloud. Yeah, cloud seeding. Just meaning that, the cloud is in the cloud, but it's actually not. But we'll go over each one in detail, I guess. Assume cloud is in the cloud. What else? What other assumptions did they make with their architecture? How about automation, like failover? Failover will work. That seems like a good assumption. Now, what else do we have? Okay, so if we apply the 5 whys to this situation, so well, there's 2 sides of it, I guess. I would say that there's the design side and there's the outcome side. And so from the design side, They probably said we need multi-AZ EC2 DynamoDB and that should be enough. Now, why? Well, oh man, I need to get better at this whole whiteboarding thing. Eraser. Okay, so why? Next one. I don't know why I'm going like with these colors. My microphone is pink, my shirt is pink, but we need multi-AZ EC2 DynamoDB. That should be enough. Why? Probably because we need 24/7 servers and like NoSQL storage and failover if one AZ goes down. Then you can say why? Well, so why do we need 24/7 servers, NoSQL storage, and failover? Okay, we need 24/7 compute power to So I heard that like the banks, some banks went down with respect to their setup. So this is in the context of banking. So they probably needed 24/7 compute power to process transactions, and they probably needed NoSQL storage for maybe like government information or like payment information. And it's getting kind of small. Okay. 24/7 compute power to process transactions, NoSQL for government information, payment info. And here's the kicker. And redundancy. And then if you take that a step further, why? Because we're a luxury region, it needs stability. Like we go the extra mile. I'm sure this will all get very ironic very quickly. Go the extra mile for our residents, businesses. Well, I forgot why. And then if you say why again, it kind of just comes down to, I would say, ultimately every cloud system comes down to trust. That's what I'm kind of realizing. Trust and reputation go hand in hand, and that is what Behind the Golf is all about. So that is 4 Ys, 1, 2, 3, 4, but I think that's plenty sufficient. And then we have the outcome. And so from the outcome, I would phrase it as a question as, why did our banks go offline for 24 hours? And honestly, I don't really have a lot of information about this, but why did our banks go offline for 24 hours? I would say, so from what I heard, like whether it was an actual drones or missiles or falling debris, fire, I guess I'm skipping a Y, because what happened was, the fire department shut down the power grid, and they shut it down because drones, missiles, falling debris, and fire is obviously a huge, safety risk, danger to society and to the data. And so how come drones were hitting? Well, that doesn't really help. But ultimately, these actually don't answer the question of, well, why did our banks go offline for 24 hours? Because the fire department shut down the power grid, which is due to drones, missiles, falling debris, and fire. Okay, so the question that I would ask is, why did the banks go offline for 24 hours due to this fire department shutting down power and drones? And ultimately, I think it's because okay, so I did some research, and apparently there was massive service failures, API slowness, and this happened due to physical damage and falling objects which caused fire. And supposedly the systems were optimized for latency, right? Meaning like speed is the most important, which is interesting. Over here, there's a big consideration for speed, and over here I'll put speed is most important. Of course, it's like everything: cars, computers, technology, whatever you want. Systems are optimized for latency and speed. And so, as a result of optimizing for speed, things were located very closely. And so, why don't we go to AWS UAE? Can we see the AWS usually has like all server location, cloud services, this service. No, I want to see the map. There's a map here. Bingo. Okay, this is what I'm looking for. So let's go to the Middle East and sovereign Middle East UAE. Okay, can I zoom in? There's no zoom button. Does it show me edge locations? Okay, I'm not really. I wish I could zoom in more. It has to be like AWS data center map UAE. Okay, Dubai South and Abu Dhabi Industrial City. Okay, data centers caught in the Middle East conflict. This is good. Wow, there's a lot in the promised land. Oh, okay. As we can see from this image, I was trying to confirm my assumption here. That's a lot in a tight space, and for a place that's very serious about data sovereignty. Man, we gotta get a data center in Afghanistan. What's going on there? They got like the highest latency in the region, even Egypt now. Yeah, so this is a lot, and it's really close. And like, this is just the nature of the geography, right? Like, everything's gonna be close. That's just how it is. But there's something to be said about they went offline ultimately. Okay, I lost my pen. My pen is gone. Here's my pen. Ultimately, it came down to they went offline because they're multi-AZ, and the reason they're multi-AZ is probably because of data sovereignty. How the heck do you spell that word? And so, you know, the kind of big thing that this is all pointing at is multi-region is not a luxury. And as a matter of fact, multi-region could have really fixed this issue, at least to some degree. So that's kind of my analysis there on that. More on this later. Okay, so we were talking about the Dubai cloud outage. And initially we started with the assumption inventory, and we took inventory of our assumptions. Some of them are crazy, some of them are not that crazy. And then we went into the 5 whys of what happened in terms of like why they made decisions to kind of get down to a core truth, which was basically like trust, reputation, and also I would say stability. And then we also use the 5 whys to kind of look at like what actually happened. So like, why did these banks go offline for 24 hours, and there was like API slowness, service failures, and ultimately it all came as a result of data sovereignty, meaning that if you want to keep everything in one place, it's kind of a security problem, especially because it was multi-AZ, but their AZs were too close together. Now, is this thing recording? Okay. Now, also, data sovereignty, and I would also say, speed. Where did I write speed? Right over here. So, speed is a huge factor here as well. Okay, so now we're going to move to our next engineering technique, which is the blank slate method. And for sake of the blank slate, let's move to a blank area. Cool, and we just have like our truths here. Okay, so I don't have too much experience with AWS, but I know a thing or two about infrastructure. If I had to analyze what happened and if I had to fix this, what would I do? So if I had to design a brand new architectural system for Dubai, I would start with, I'm not sure if I should look at the problems that happen and design for problem, because that's not a great technique either, but I'll just take these. Oh yeah, I was supposed to like change this to like it is speed, but in reality it is what's the right word? Locality. No. Alright. So V1 derogatory word. No. I don't know why I can't remember this word. Within reach. Just around the corner. This is what I'm looking for. That is what I'm looking for. The word I was looking for is proximity. So let's give this a shot. So first of all, when we do this blank slate method, our only restriction is physics, and I'm also gonna just, for simplicity, assume that budget's not a problem. Now, in terms of applying the blank slate method, I would break it down into two things: physical infrastructure and digital infrastructure, right? Because in our assumptions, cloud is in the cloud, but it's actually not in the cloud. It's just someone else's computer, right? And that's where like failover and speed and natural or disaster or like war, multi-AZ is enough, and multi-region is overkill or like a luxury thing. So we're pretty much going to design against that. And so by this I mean the first thing that I would do is I would say, let's go into Google Maps. Okay, Dubai. It's fine. Okay, UAE. This is, wow, in retrospect it's kind of crazy. So why don't we measure just like a random from here to there. Wow, under 500 kilometers. What is this protected area? They should have put the data center there. Oh, it's a nature preserve. Okay, so 450 kilometers. Okay, that's great, because from what I understand, fiber networking is typically good up to 500 kilometers. And remember, budget's not an issue here. So the first thing I would leverage by using physics is this fiber networking principle. And so in that sense, what I would do is I would use multi-AZ. However, the AZs need to be far from each other. Maybe not 500 kilometers, but the more the merrier. Because what we had was, we had like an AZ here and an AZ here, and then boom, you have a problem here. These are nearby for speed, for latency, for extreme speed. But the problem is, since like one of these got physically affected, the fire department came, they shut down the power grid, and they had to, turn everything off. And then obviously that's gonna affect the other AZ. So I think the AZs need to be far from each other, somewhere between 500 kilometers, because you can still get really good speed with fiber networking. Also, speaking of fiber networking, if I looked at the very physical perspective, I would say that, like, okay, so let's say from, you know, one data center to another data center, you have a physical fiber line, right? I don't know, will it go under the highway? Will it go under the water? Will it go in the desert? Beats me. But what I would also do is I would set up shadow connections so that even though, so there's a redundancy built into the physical infrastructure too. So, oh, that is not what I wanted to do. So, can I move this after? So yeah, I would make it so that, okay, if something happens here and this line is gone, okay, that's okay, because we still have two good fiber lines connecting our data centers. And so I would definitely implement this kind of like redundant fiber networking. And then obviously that'll cost a lot of money. And so if these AZs are really far from each other, that's really good, because if something happens to one, the other one will be pretty isolated. And I would also go for a stateless infrastructure. Like if we're talking about EC2, right? Because if it's stateful, it's going to be really hard for it to come back up in a situation. So this would probably mean microservice architecture, because this would decouple systems. And also, like, you know, depending on demand, microservices can scale on their own instead of like the whole thing scaling up. It's kind of more cost efficient. And then I would also, I'm sure like UAE has some connections with some country. Let's say like Switzerland, right? Let's say Switzerland in Zurich. You can have a probably like private S3 replication or something like that, where you'll basically have like a, you know, like a data center or two in like a completely different country, and everything will be replicated, but like no one would probably know about it. This is probably all behind the scenes. So that way, if something happens here, like, so first of all, we should be able to fail over to another AZ, and if that AZ doesn't work, then ideally we need another AZ, ideally one that's far away, and they should be branched so that, you know, if there's one issue in one area, it should be able to be like far enough away. But then also, if for whatever reason the whole region's like destabilized, like things still need to run, right? Like people need to move money, people need to make decisions, and so for that reason, it'd be good to have a kind of like, you know, cross-country replication as well. And actually, as another layer before that, since this is all like physical cabling and fiber, we also have like Starlink, right? Shout out to Elon. So we have Starlink, and these data centers, I really have no idea how this works, but like I would make them satellite enabled as a backup, because obviously it's won't be great for speed, but I don't know, is Starlink fast? Is it getting good? It's definitely not faster than fiber, but yeah. So, and then in terms of like actual architecture, they said they were using EC2 and DynamoDB. Oops, that's ECS. So it is EC2, and it's probably best if it were stateless, because if something goes down, something needs to come up quickly to replace it. That's where like the microservice architecture comes into play. For DynamoDB, okay, so it's like NoSQL database. I don't see any problem with that. Maybe I'm not using the blank slate method well enough, but it's crazy to think that like a country that had probably the most funding for these kinds of projects, like, and like the best architects, they still ran into a problem, right, which is hard to solve. So this is all very easy to say in retrospect, but in terms of the actual services that they're using in EC2, okay, I'll make one comment. Like, obviously, like my experience is limited here, but I'm thinking if there's a VPC, right? Okay, I think I need like a bigger shape. What time is it? 9 o'clock. So I would imagine if you have two regions that are really close by, is it safe to assume that those services are in the same VPC? I don't know if that's possible. Let's find out. Let's go to check. What I would say is, can two AWS AZs be in the same VPC? It is a standard and recommended architecture for high availability. That's crazy. Okay, well, what's the drawback for having 3 AZs in separate VPCs? A discouraged network latency, bandwidth, high availability failure, management overhead, operational toll. When would you use separate VPCs? Strict regulatory isolation, account separation, or disaster recovery? Wait, what? But having separate VPCs would isolate failures to the AZ. That's a sharp observation. You're touching on a legitimate architectural debate, technically correct, that has stronger isolation by the AWS. You're solving the wrong problem. The blast radius argument. You're thinking about failure isolation. If you have VPC A, okay, so we have AZ, each one is in its own VPC. Great, only VPC is affected. B and C are untouched because they're in separate VPCs. This is true at the control plane level. What the heck is a control plane level? Here's why this really makes sense for production workloads. AZ failures are rarely VPC wide. When an AZ has an issue, it almost always power failure in specific data center. I don't know, DeepSeek knows something. Networking issue. Okay, it's not about racks. API throttling. I think DeepSeek entered the chat a long time ago. In a single VPC with 3 AZs, your EC2 instances in the affected AZ go down. In separate cross VPC load balancing global accelerator. Not automatic DNS What is that? Time to layover? Time to TTLs. Oh, I don't think they're talking about security. Time to live, yeah. So your time to live adds, oh boy, it's not automatic, it just adds 120 seconds. I don't think that's a big deal at all. Or is it? You think that's for everybody? Like each request? Or your isolated VPCs are still running, getting traffic, single point of failure, control plane, data plane distribution, data plane distinction. Data plane, your app track, highly available, complex routing, control plane, VPC, API, subnet manager. Let's see this. How about Dubai? Provides a powerful real-world case study that directly answers your questions, shows the exact risks of putting each AZ in its own VPC versus the resilience of having it all in one. 3 AZs, these 3 zones that are designed to be isolated from each other to prevent a single failure. Okay, so this is what they tried. A fire caused a severe widespread outage. 2 out of 3 AZs in the region were ultimately impacted. 1 VPC with 3 AZs in the scenario. Let's apply to architecture. Your single VPC has subnets in all 3 AZs. When 2 AZs fail, the third one remains operational. The outcome: your application all stays partially online. A load balancer automatically detects. Sorry, I'm just adjusting my. On one bar. A load balancer automatically detects instances and failed self-full traffic. Reduce capacity, no downtime. You have 3 VPCs, each locked to a single AZ. 2 of them go down. 2/3 of your infrastructure goes offline. No automatic failover. Cannot route traffic across VPCs. I don't know. First of all, I don't know how DeepSeek knows that. They had. How did you know that their VPCs were separate? I don't actually know. Okay, well, I don't know though, because they still experience the problem. This is a much harder problem to solve than I thought. Oh, no way. Wait, what is the source? not really clear. This is a deep question. Honestly, I might put this on the board. Okay, but anyway, so either you have three EC2 instances within one VPC. So this is your VPC, and then you have EC2, and so if one goes down, you go to the next, and if that one's also down, you go to the next. But if these are still physically really close to each other, which they were, I feel like it's still not a great setup. So maybe the main thing here is not to isolate each instance to its own VPC, but more so you should geographically isolate all the availability zones. And then, oh yeah, these are not instances, these are AZs. I mean, it just depends on what level you're looking at it, but if you have 3 AZs within the VPC, yeah, well, this needs further investigation, but I will definitely learn a lot here. That's the main point of the exercise. Okay, so let's go over what we did. Man, I kind of hate this mouse. There's no like drag. So we have the Dubai cloud outage, EC2 RDS DynamoDB disrupted slowness on API calls. First, we started with making a brief assumption inventory, and the biggest assumptions they made is that cloud is in the cloud, meaning that, you know, there's no like physical aspect of things, like it's in the cloud, so we'll be fine. Also assuming that failover will always work. This depends on the architecture of your system, physical and virtual. And they really prioritize speed, which meant that their data centers were in very close proximity. And of course, no one could have predicted that they would have something really dangerous like that happen, because it's been a very safe region for a long time and nothing has happened in a very, very long time. Also, multi-AZ is enough, meaning like, you know, multi-region might have been a good idea. Because people tend to think of multi-region as like an overkill luxury. Also, in most countries, I would imagine that multi-region is a bit overkill, right? Because most countries have a large geographic reach, whereas the UAE, like from end to end, is 500 kilometers, as we measured, which is something that wasn't even, you know, really utilized in a sense. But it also depends, because like, I don't know, I was looking on here. Why don't we actually look at the satellite view? How do I satellite view? Maybe if I close that, bingo, layers. All right, so look at this. Yeah, so this is what we measured. This is all desert, right? Like, similar to Canada, almost all of the actual infrastructure is by the shore, which is why they probably can't just drop a data center in the middle of the desert. It has to be within like the previous infrastructure, but the problem is it's too close, and because it was too close, that caused some issues. Also, after that, we started looking at the 5 whys, and so what we did is we looked at the design, and we basically said we need multi-AZ EC2 DynamoDB. That's all we really know about their architecture from doing some Googling. But why did we need this multi-AZ system? It's because they need 24/7 servers, NoSQL storage, and failover. if one AZ goes down for backup. And the reason for that is because we need 24/7 compute power to process transactions, NoSQL for government information, payment information, and redundancy. Why do we need that? Because we're a luxury region, stability, go the extra mile for our residents, businesses. They really wanted like the best system, probably, right? Although ultimately it came down to trust, reputation, stability is what like the core of the 5 whys came down to. Then we also can apply the 5 whys to what happened. So it's like, why did our banks go offline for a day? It's because the fire department came and shut down the power grid after an incident. And there was like physical damage, which people rarely think about. People always assume like, oh, you know, we'll just get like overwhelmed and like our auto scaling will fail, or like a security threat. But like people don't think like, okay, what about like falling drone debris like hits our data center, which is not funny. It's very sad. But so these systems were optimized for latency and speed. By that I mean like things were in very close proximity. They were doing multi-AZ, but like we saw, the region is very small, and so multi-AZ is not that far away. And they didn't have like a multi-region probably for data sovereignty and speed, because you know, when you prioritize speed, you kind of get like things in closer proximity, and also they probably don't want to put their information in another country because they like to keep things private. And then we went into the blank slate method, and so we said, okay, well, how would we design a architecture where this would, you know, if we had no constraints, like only physics constraints, no budget constraints. So first I started with kind of the physical architecture. I kind of tend to think towards hardware first, and so, you know, in terms of physics capabilities, like fiber networking is good for up to like 500 kilometers. It's really, really fast. And so first of all, these data centers were too close together, and so I would put them much farther away from one another in order to, you know, preserve the like the individuality of each AZ. And then also I would implement like shadow connections. For example, if you have one fiber line going down like through the middle of the city, you know, who knows, what if that gets missile striked, right? Then you're gonna need another one, and like everything is running on the back of these servers. And so I would have a shadow, like kind of like a shadow connection. So you can have like one, you know, fiber line here, and you can have another fiber line taking like a less standard route, and another one, just depends on like how far you want to go down the redundancy tunnel. And also as a backup to that, I would use satellite, like satellite as a backup for that backup. So like in the case where, let's say like, you know, we have like 5, I don't know, shadow networking lines, fiber lines in the ground, and God forbid there's like an earthquake and like those things get destroyed, right? Then you would need to have like a satellite connection for these data centers to stay online. And also there's something to be said about IoT sensors and devices. So for example, like, you know, checking for kinetic activity, like earthquake, like missile strike, like natural disaster, that kind of thing. And that, so we can keep these AZs safe. They need to be like farther away from one another, but they still need to be enabled. And then as a last ditch effort, I would have like a cross region in another country, and like have like some private replication, so that, you know, if something like extremely bad were to happen and, you know, AZs are all offline, like we still need to have like a true sense of sovereignty and safety. And so basically this is like kind of the physical side. And then on the digital side, when we come to like stateless EC2 servers, because if they were stateful, it'd be very hard for them to, you know, go up and down. And so we always want to kind of move from stateful to stateless, from what I understand, because stateful EC2 servers need more manual configuration. They need to be tuned. Whereas for a stateless architecture, we would ideally like to have things like, self-replicating, self-healing, and then they're using DynamoDB because they probably had complex data that needed to go in an NoSQL table. And then along with the stateless EC2, you kind of need microservice architecture to decouple systems and scale with demand individually instead of like throttling the whole thing. And then after that, we kind of got into this discussion about, okay, like if I have a VPC, should I have each data center in its own VPC? Would that create more redundancy? Or does it make more sense to have one large VPC and have each availability zone within one broader virtual private cloud? And to be honest, I couldn't really get to the bottom of that because we don't know what AWS UAE had implemented. So it's very hard to say, and so I'm gonna do some more research on that because I would like the answer. But yeah, so the whole point was we analyzed Dubai cloud outage from a fundamental first principles engineering perspective, in the sense that we took inventory of our assumptions and we used the 5 whys to come down to some core truths in the design of the architecture and also what happened. And then we used the blank slate method to see how we would try to design a fresh system from scratch with only having a physical limitation. And yeah, so that's kind of the breakdown. Hopefully this is not really boring, but if it is, that's okay, because that's the process of learning.